Okay, picking up where we left off, we're on page 102. We're talking about what the Ethernet frame looks like. We talked about the preamble, and the preamble is just a pattern that's not likely to appear in data and is sufficiently configured so that it's sort of immune, most likely immune to noise. You have a start of header, kind of a start of frame, kind of a scenario, a destination, a source, and then this cool little doodad here that either is the length of the remaining packet, because remember the people who wrote Ethernet said, look, we don't have a clue what we're going to put in here. So we don't really know how big this thing is, but there's going to be a maximum, and the maximum is 1500 bytes. And if you do all the rest of the math, you can figure out what the maximum size of an Ethernet frame is. And once again, what controls the maximum size of an Ethernet frame? Well, it's physics, it's signal propagation, speed of light, cable length, all that stuff. In other words, if given a frame size, I know exactly how long it takes for that frame to go from one end of the cable to the other end of the cable. So it's all physics. And this is, thank goodness, is not a physics class. Otherwise, I'd bore you with all the goofy math. Okay. So the start frame delimiter, destination, and this guy, the length. So if it's less than 1536, okay, then it's probably going to be the length. 1536 is the total thing here. So if it's less than that, then that's really how long this frame is. Otherwise, if it's greater than that, it's probably going to be a code telling the machine what's inside the payload. So, for example, if this code right here is 2048, that tells the machine that the payload is an IP packet. Now, that doesn't necessarily mean that every type of packet being sent in, every type of payload has to have a particular type. Because when these guys were put together, years and years, we're talking about, 1977, right? So the guys who put this stuff together, if you have a brand new type of packet that you're wanting to send, just pick a different number. That's all. Just, make it short and you're done. Make it go to length rather than telling you what it is. Okay. Let's continue. So the data, which is about 1500 bytes, and then the frame check sequence. Okay. So here's some trivial pursuit. Do you see here where it says the minimum size of the data is 46? Why? I'm not exactly certain. I'm serious. I really don't know why they picked a minimum size for the payload of an Ethernet frame. I don't know. But if you add the rest of the junk to it, the 7 bytes over here and 1 byte over there, so 7 is 8 and 6 and 6 and 4. Anyway, it turns out that 72 is the smallest Ethernet frame that you can get. And 1526, or is it 1536? I think I have a typo here in my notes. 1536 would be the largest that any frame could be. Okay. So now we've beat this together. This is what layer 2 is all about. I'm organizing my data into a frame, and the frame has got parts, and the data payload, that whatever's being sent, is in the middle of this thing. This is what it's all about. Okay. But continuing, they talk about the Ethernet addresses. So these two guys here, the destination and the source address. So they're 6 bytes, so that's 48 bits. 48 bits in length. So what I'm going to do is I'm going to go here to my machine, pop open a command prompt, and type ipconfig/all. And what it's going to tell me is what the MAC address is for my particular machine. So here's an Intel Pro blah 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 adapter, and here's what the MAC address is. The MAC address. I said it, and I didn't even describe what that is. Okay. Some people view layer 2 as having two different things of doing. One's called a media access control, and the other's called a link control. The book doesn't make that distinction here. So in other books and in other types of thinking, media access and link access, link control, So this was just called a MAC address. And in fact, it's such a prevalent term that we talk about, what's the MAC address of your wireless card? Wow. My wireless card doesn't really have, a media access kind of a scenario because it's not using CSM, it's not. So bottom line is, it's a term that everyone uses. Thankfully, Microsoft calls it the physical address. Good. All right, let's back to here. So this physical address is in two parts. They have 3 bytes, which are designed for. Okay, here's how it works. In the early days, every manufacturer got a range of addresses to use. And so if you were 3M, a very good vendor of Ethernet cards at the time, if you were 3M, you were given by the authority your unique identifier for you, the manufacturer. And then when you started making products, you started with 1 and 2 and 3, and so this was given to you, and this is one that you just rolled over and over and made sure that no 2 manufactured cards coming off your company would have the exact same MAC address. Okay, cool. Now, admittedly, there is some way you can do this. There is a bit that can be set in the first one that basically says this is not an organizationally, not a globally unique identifier. Instead, this is a software-defined one. And you have to have that, for example, in some scenarios where I'm making a virtual machine. And so I have a physical network card, and then I have to pretend like there's another network card here. Well, I have to have a MAC address for it. It's not a physical card, but I still need a MAC address. So therefore, I come up with this locally administered one. Okay, kind of sort of makes sense. I'm going to go to a website where you can go and look up a MAC address. So here we go. Here's this MAC address lookup guy, and here's a valid MAC address that I pulled off my machine. And so I'm going to go to this utility. It's aulrjohn.com. I'm just going to paste this guy in here. And so that's my MAC address. I'm going to hit the button, and it's going to come back and say that the first 3 bytes, because remember, it only cares about the first 3 because the rest is unique, is made by CISK. Yay! I have an ASUS motherboard in my machine, so it has correctly detected the manufacturer of my network card. Now, I will tell you a story. We bought a whole bunch of network cards 10 million years ago and plugged them all in, and I was kind of looking at them all, and I noticed one of them had a really screwy looking MAC address that didn't match any of the others. And I thought, well, how is that even possible? We all bought them. They all came in a cardboard box, and we installed them all in the same machines. How in the world can one of them be wrong? So I was kind of curious, being the curious kind of guy that I am. So I shut that machine down and pulled the card out and kind of looked at it. And one of the pins was bent on the little EEPROM chip that had the address. I went, So I pried the chip off, straightened the pins, plug the chip back in, and ding! Then I got the right kind of MAC address that I was expecting to get. Now, could that have caused a problem? Yeah. Was it likely to cause a problem? No. I mean, geez, what are the odds that somebody had that random number somehow matched some other vendor, and I just so happen to have the exact same? It's infinitesimally small, but hey, what the heck. Okay, so back on topic, we're talking about this hub scenario. So I want to go back to this picture here of this hub. All right. The problem is there are 2 devices that look almost the same, a hub and a switch. So let's just talk about this for a minute. An Ethernet hub is this thing. It's a bus technology. It's not a star. It looks like a star, but it's not. It blindly copies whatever data. So if this guy sends a packet, it doesn't look at it. It doesn't care. It's dumb as a rock. It's going to look at it and go, okay, dude, let me just pass that along. So it just stores and forwards every single packet. Doesn't filter, doesn't look at them, doesn't do anything. So it's dumb. So you could call this working at layer 1. Now, that's not technically correct, but working at layer 1 typically means there's no smarts. It doesn't look at the contents. In other words, from its perspective, it really could be just signals. Now, admittedly, it's not, because it actually takes the frame, stores the frame, and then sends it on. So it's not like it's amplifying the electrical signals. It really is storing the frame and forwarding it. So it's only kind of a description if you called it a layer 1 device. A switch, on the other hand, really is star topology. And the problem is, when you go look on the shelf and buy one of these things, they look absolutely the same. Now, the weird part is, there's hardly any hubs around anywhere today. I doubt you could go to an electronics store and buy a hub. It would be hard to find. Almost all of them are switches. Okay, switches really are star topology. And because it's a star, it only sends data inside the machine, inside the switch. It's kind of sort of a hub, a miniature hub inside here. But it only forwards packets that belong to that one machine. And only forwards packets that belongs to that one and that one. So it does actually do a lot of filtering and a lot of thinking behind this thing. Okay. So how does it know that what the MAC address is over here? Well, it starts out, a switch, starts out being kind of dumb. It says, look, I've just been powered on. I don't know what's going on here. So I'm just going to send all my packets to everyone until I can learn who's at the other end of each one of these cables. So I just blast out to everything. And then after I send the blast out, I go, hey, this guy over here is MAC address number 4. Good. And so on port 2, this guy is MAC address number 22. Great. It kind of builds a list of MAC addresses. Then once it's built the list, then it turns into the smart mode. It starts, here's a packet going to 22. Oh, 22 is on port number 4, and boom, sends it on its way. So it's a learning bridge is what they call these things. Okay, so let me ask you a Trivial Pursuit question. Can I get 100 megabit Ethernet, or a gigabit Ethernet, a gig E cable, or a 100 base T cable? Can I get one of those in a hub? What do you think? The answer is no. That basically the 100 base T and above was never designed for a hub. It can do it, okay? It is allowable in the standard. However, it has never been implemented that way. All the cables and all the network cards and all of the switches were designed for this point-to-point kind of filtering going on. Okay, kind of weird. All right, so let's say, for example, I'm moving on to page 107. Let's say, for example, I've got a setup here. Let me get to back where I was. And here's my network. And then, I have a new employee comes along, and he accidentally takes an Ethernet cable off of one switch and plugs it into another switch. And so what I actually have now is a loop. So a packet could get in there and kind of just go away, just loop over and over and over and over and over. How do I deal with that? Well, first of all, this is remarkably easy to do, okay? I'm telling you, just from experience, it's pretty easy to accidentally create a loop. Now, before we talk about how loops are bad and how do we fix them, are loops bad? Is there a scenario you can think of where a loop might be good? We'll answer that question as soon as we come back. We're at the 15-minute mark.